Okay, you'll remember that when you're dealing with an empirical formula, it's the lowest whole number ratio. So for this one, NO2 has two subscripts. It has a subscript of 1 and a subscript of 2, and that's in the lowest whole number ratio. You'll also remember that the molecular mass is a multiple of the molecular mass of this, or the gram formula mass of this. So we find the gram formula mass of NO2, nitrogen, there's one of them, it weighs 14. Oxygen, there's two of them, and they weigh 16 apiece, so that's 32, and that's 14. So this thing weighs 46 grams per mole. All right, they gave us in the problem that the molecular mass, that means the mass of the molecule, is 92 grams per mole. 92 grams per mole divided by what the molecular mass or the gram formula mass is of the empirical, which is 46 grams per mole, tells us that the molecular formula is going to be 2 times, I divided them, 92 divided by 46 is 2 times bigger. So I guess I should have made this big white space before I started the problem, but now that we know that it's 2 times bigger, we have NO2. I want to multiply everything by 2, so we've got 1 as the nitrogen subscript. We're going to multiply that by 2. We're going to get nitrogen has a subscript of 2, and oxygen has a subscript of 4. So our formula, our molecular formula, is going to be N2O4. Okay, this question is worked exactly the same way. We are given an empirical formula of CH2. We know that the gram formula mass of CH2 is going to be 12 plus 2, which is 14 grams per mole. If you need to see how to do gram formula mass, go back and watch the gram formula mass video. We also know that the molecular mass of the thing we're looking for is 70 grams per mole. So we're going to take that 70 grams per mole, we're going to divide it by 14 grams per mole, and we're going to find out that the molecule is going to be 5 times bigger. So we've got CH2. Instead of a 1 here, we're going to multiply it by 5, so we're going to get C5H10. Okay, in this question, now they didn't give us the empirical formula, they told us the percentages. So 40% carbon, 6.7% hydrogen, and 53.5% oxygen. We have to now calculate the empirical formula just like I did in the other video. So I'm going to go ahead and pause and then do that work and come back and explain to you what I did. So here we have step 1 where I took the percent and made grams, percent grams. I divided by the gram formula mass of each individual element. So carbon is 12, 40 divided by 12, I got 3.3. 6.7 divided by the gram formula mass of hydrogen, which is 1, gave me 6.7. And 53.5 divided by 16 grams per mole for oxygen gave me 3.3. Then I have to make my mole ratio. So here's my mole ratio, but they're not whole numbers. So I'm going to divide them by the lowest one, which is 3.3. Okay, so now we have the empirical formula of CH2O. Just by dividing these, let me get a pointer, I got a ratio of 1 to 2 to 1. All right, I'm going to change colors now, and we have to finish the question because they're asking us for the molecular formula. What is the molecular formula? Well, we calculated the empirical formula right there. And the empirical formula's gram formula mass is going to be 12 for the carbon. Carbon, there's one of them at 12. Hydrogen, there's 2 of them at 1 each. And oxygen, there's one of them at 16. So that's going to be 30 grams per mole. Well, they're telling us that the thing that we're looking for is going to have 60 grams per mole. So 60 divided by 30 is 2 times bigger. All right, if it's 2 times bigger, then the carbon is not going to be 1 as a subscript, it's going to be 2. Hydrogen is going to be 4, and oxygen is going to be 2. This is the molecular formula. It has an empirical formula of this, but it has a gram formula mass of 60. Okay, so I'm going a little bit quicker here with this one, but you can see up here in the question it's 64.9% carbon, 13.5% hydrogen, and 21.6% oxygen. So I found the moles by doing the grams over gram formula mass, grams over gram formula mass, grams over gram formula mass, and I got the mole ratio. Now all I have to do is I have to do carbon, oh that's yellow, carbon is 5.4, hydrogen is 13.5, and oxygen is 1.35. Good. I know, excellent, right?
Yeah,
Excellent,
amazing.
doctor.
That's great, yeah. Can you run me a pass to go to Eastman's car?
Yes.
Thank you.
Eastman's car?
Yeah.
I don't know if I can do that, can I?
I mean, I don't have a teacher this period, so I don't,
What do
I
you
don't know
need
what they
in the
want me to
car?
do. I have flowers for my girlfriend.
Oh,
Yeah, right? You can't say no to
I
that.
can't say no to that.
Exactly.
Where you go?
How much do you round by? Wait, do you do the times out?
I'm right back in class. You could say it's my class. Okay? All right. All right, so for this one, in the empirical formula, which is right here, the empirical formula has a gram formula mass of 74. And that matches, let's pull out a pointer. I'm going to pull out a finger pointer. It matches the 74 grams per mole that they're looking for the molecular mass. So that means our molecular formula is going to be C4H10O1. It's still an empirical formula, but it's also a molecular formula because it has the right molecular mass. Next question. Oh, no, I didn't finish the other two. Oh, yeah. All right, for this one, they gave us percentage of carbon, hydrogen, and oxygen, and I'm in the process of changing that into an empirical formula. Same as I've done for every other problem, I've taken the percent, I've changed it to grams, then I divide by the gram formula mass, and I got a mole, mole, and mole for each one of these. Then I'm going to set up my mole ratio. So carbon is 4.54, hydrogen is 9.1, and oxygen is 2.275. I'm going to divide through by the smallest number, which is 2.275. So I got an empirical formula that looks like this, because 4.54 divided by 2.275 is 2, 9.1 divided by 2.275 is 4, and oxygen's 2.2 divided by 2.2 is 1. So that's the empirical formula. Now we have to find the gram formula mass of that empirical formula. Okay, so right here, I'll do it in green, I calculated the gram formula mass of this empirical formula. They told us that the molecule has a mass of 88. It's right there. So 88 grams per mole divided by 44 grams per mole is 2 times bigger. 88 is 2 times bigger than 44. So I have to make my empirical formula 2 times bigger. C4, 2 times 2, H and O times 2. So we're going to go H8 and O2.